Okay, so we're going to look at how to do specific heat. So these problems here, we have our triangle. Here's the equation Q equals mc delta T. We have our change in temperature, delta T is final minus initial. And this is the idea of specific heat. So to solve for this, we're solving for heat, which is Q. So to work for this triangle, we're going to say that it multiplies going this way, and it divides going this way. So if we're solving for Q, we cover Q. So it's going to be M times C times delta T. So our equation is Q equals M times C times delta T. And then our delta T is our change in temperature. So delta T is going to be equal to our final temperature minus the starting temperature. So we're going to do TF minus TI. I for initial. All right, so let's look at our change in temperature. The change in temperature is going to be the final one. So it cools from 200 to 75. So this is going to be our final temperature. And then our initial temperature is going to be this one here. So to subtract 75 minus 200, we're going to do that subtraction. So on our calculators, we are going to type in 75 minus 200, and we're going to get negative 125. All right. So that's the first bit. All right, so the next one, let's write out what we have. We have grams, so grams is mass. We have C, and we're solving for heat, Q. So we know that our M is 200. We know that the C is 0.385, and we know that the delta T is given here. So we're trying to solve for Q. So this is going to be Q equals MC delta T. So we just plug in. Q is going to be equal to our mass, 200, times the C, 0.385, times our delta T, which is negative 125. All right, and let's multiply all these out. So we have negative 125 times the 0.385 times 200. So our Q is going to be negative 9,625, unit being joules. All right, so that's the first one. Okay, second one, we're going to do the same thing, but here we're going to be finding mass. So we're going to be looking for M. So what mass, M, is required to do 2,000 joules of heat? So J for joules is heat. So this is going to be Q. We have our change in temperature, so we have two temperatures. So we have our initial temperature and our final temperature, and we're given our C. So let's write out the variables. We don't know what mass is. We know that Q equals 2,000 joules. We know that our C is 0.902, and our delta T is going to be the final temperature, 175 minus 100. So this total should be from 175 minus 100, we're going to get 75. All right, to solve for this, we're going to be looking for mass. So to solve for mass, it's going to look like this. Q divided by C times delta T. So our mass, M, is going to be Q on top divided by, so this line, C delta T on the bottom. All right, so then we just replace. M is our 2,000 divided by our C, which is 0.902, times our delta T, which is 75. So in this case, we're going to multiply the bottom and divide top by bottom. So our mass should be 2,000 divided by, let's do the bottom first, 0.902 times 75. So we're going to get 67.65, and then we'll do 2,000 divided by this. So 2,000 divided by 67.65. We're going to get a total of 229.56 grams. All right, and then that's the mass for the second one. All right, let's look at the last one. We're going to find the change in temp. So we want to find the change in temp, which is going to be our delta T of 150 grams of water, M, that receives 2,000 joules of heat, Q. We're given our C here. So again, delta T, we don't know what it is. M is 150 grams. Our Q is 2,000 joules. And our C is 4.18. All right, so to solve for this one, we're looking for delta T. So again, we're going to cover delta T. It's going to be Q over M times C. So Q on top over M times C. This is our delta T. So delta T is equal to our Q, 2,000, divided by our mass, 150, times the C, 4.18. So 2,000 divided by 150 divided by 4.8. So we'll get a total of 3.1, round this up. So 3.19 degrees Celsius. That's going to be our change. All right.